Hello, everyone. Happy Friday. Uh, it's been a while since I've done this, but I'm back at it. More AI stuff today. I'm just trying to put my music a little bit quieter, so I'm not distracted by it. There you go. All right. So, what are we doing today? So, I'll be looking at mem0. Mem0 is it came. Oh, let me switch. It's from the same team that brought you Embedchain. So I was looking at Embedchain a while ago, and it looks like they came out with a new project. They or either renamed it, right, or changed direction, I guess. And it's called the new project is called mem0 and is the memory layer for personalized AI. So I'll be looking at this. Um, Also, I just realized that I can't stream to Twitter or X anymore because I don't have a premium account. So, well, you're either on YouTube or you are on LinkedIn. Anyway, all right. Well, let's get started. So, GitHub repo. Let me paste this in the comments if people want to check it out. So, there's a GitHub repo, but there's also the docs page. So mem0.ai just redirects to GitHub repo. But I guess I'll go through the docs page first, and I already have set up like an empty Python file. Let me make this a little bit bigger with empty Python file with OpenAI key already in there because I'm assuming I'll just use that, and I'm assuming it works with that. All right. So what is mem0? So mem0 provides a smart, self-improving memory layer for LLMs, which enables personalized AI experiences across applications. Okay, so reading this without going any further. So what I think about this right now, well, I as I read this, is that it's a database that stores your interactions with an LLM in some sort of a way. I don't know what self-improving means. Maybe it like reevaluates whatever is stored based on your like new responses or new data that it gets. I'm thinking, um, trivial example. I would say I like pizza, and then next time I would say, well, I like pizza with Italians, please don't kill me with pineapple. And then that would be self-improving layer, maybe. I don't know. It would be self-updating, I guess. But and then the across applications part, I'm guessing that's why I'm guessing it's a database, so you can plug it in across multiple applications. But I wonder if there's like a hosted version as well, right? Where you would that would allow a cross application experience as well. All right, so core features, user session, and AI agent memory. So retains information across user sessions, interactions, and AI agents, ensures continuity and context. Adaptive personalization continuously improves based on based on user interaction and feedback. Okay, so there might be a way to thumbs up, thumbs down to provide feedback in a different way. So it goes and re-updates all the everything it knows about you, I guess. Text is hard to see. Is it easy to enable 4K? I don't know if I can enable 4K, to be honest. I'm streaming with the like full like highest resolution that StreamYard offers. So I don't know. I'm sorry. No, so StreamYard, unfortunately, they don't support 4K. Sorry about that. I zoomed in a little bit. Maybe that helps. All right, so developer-friendly API. So offers straightforward APIs for integration. Okay, platform consistency, consistent behavior and data across different platforms and devices. Managed. Okay, so there is a managed service. So what are some common? I'll go through the quick start, but I just want to read to the end of this page. So what are some common use cases? So learning assistants. So learning assistant remembers user preferences, interactions progress, etc. Support agents, more accurate. Okay. Healthcare assistance, treatment plans. Okay. So basically anything that requires like a long-term context, I guess, right? Or memory, right? Productivity tools, gaming. Okay. So how is it different from RAG? Okay, it offers several advantages. So, entity relationships. So, mem0 can understand and relate entities across different interactions. Unlike RAG, which retrieves information from static documents, this leads to deeper understanding of context in relationships. Be curious how this works. We'll probably see it in the demo. Recency, relevancy, and decay. So, by the way, RAG. I don't know people watching, like if everyone knows what RAG is, but the idea with RAG is that you, let's say a chatbot example. I ask a chatbot a question, right? I don't know. I ask it a question, whatever it is, doesn't matter, right? And it gives me an answer A, right? I know the answer A is kind of okay, but if it had more relevant, let's say relevant, newer information, it would provide me a better answer. So with RAG, what you're basically doing is you're saying, let's say, uh, what is A, right? And then, so this is the query, right? And then you would get back an answer that says A is ABC, right? Some answer, right? But I know that A is ABC, but also can be XYZ, right? So this is the extra information, right, that LLM doesn't know about necessarily from its training, right? So what you could do with RAG is, so this would be your prompt. So let me call this prompt, right? Prompt initially, right? And this is the initial answer. So with RAG, what you could do is you could say prompt is what is A, right? Prompt will be the same. And then with RAG, you would say, you would encode this. So you would do encoding for that string, right? And then you would search the database, documents, anything else that contains the relevant information. And then this would then return you, let's say, some context, right? So what you would do next is, before you send it to the LLM, you would say, answer, let's say answer users query based on the context. So you would say context would be whatever you retrieved from the database, and then query would be what is A, right? So previously you were just sending this single string, the single query, right, question as a prompt to the LLM. Second step with RAG, what you're doing is you're saying, you're taking that prompt, you are either encoding it and then doing a like vector search in your database, whatever, to extract, to get the relevant information, relevant context. But remember that this doesn't have to be vector DB. It can be anything. It could be a normal database if you want to, right? And basically you get anything else that's relevant to the user's prompt, and you build up or create a context, right? And then what you do is you restructure your prompt to basically say, well, here's some context. Now answer that same question, right? So the idea here is, with LLM knowing this additional context, it'll better know how to answer your question. Anyway, so that's RAG, right? Very, very quickly and in a not good way explained. But mem0 is different, right? So it's different. It can understand and relate entities across different interactions, right? So RAG just retrieves the information from static documents, from vector DB, et cetera, et cetera. So mem0 prioritizes recent interactions and forgets the outdated information, ensuring the memory remains relevant and up to date. Retains information across sessions, maintains continuity, interactions, essentials for long-term engagement. Improves the personalization based on interactions and feedback. Okay. And it can dynamically update its memory with new information and interactions, unlike RAG, which relies on static data. True. Yeah. So RAG is, so the way that you create this DB, I guess, is you ingest a bunch of information, a bunch of documents, a bunch of sources that you have, and then you store that in a database, right? So this one is saying that it dynamically updates the memory with new information, which, yeah, well, and RAG relies on static data, assuming you don't go and refresh your static data, right? Powerful tool for developers aiming to create personalized and context-aware AI applications. Slack, Discord. All right, let's go to a quick start. Get started quickly. All right, so let's install this. So we'll do pip install mem0 AI. And I'll delete this. All right, and then you basically create memory. Okay, it's still installing. So basic usage. So we're going to create a memory. We'll add something to the memory by the user and store it by some metadata. So this looks very similar to the way that you would store data in vector database, right? This would get encoded, right? And then user ID and metadata would be stored as metadata. So let's do this. So we'll do from mem0 import memory. And then we'll create the memory object. And we'll say add something to the memory. Okay, so we'll add likes to play cricket on weekends. So user is Alice, metadata, category. Okay, so category hobbies, I guess. Hobbies. And then what do we get back? We're just going to get back this event. So let's do main. So it looks like it is doing something. I wonder what it did, right? Because it's okay. So we got back the ID. The event was add, and then the data was whatever the data is. But where is this memory stored? So we add this. So let's do all memories. M dot get all. Okay, you can get it by user agent run, whatever run ID is, or just get all of it. So let's print this out. This is just CRUD operations, I guess. There you go. Okay, so it does do some magic behind the scenes somewhere. I don't know where, because look, I added it again and it says it was an update. Likes to play cricket and plays cricket on. Oh wait, was this like this? Oh no. So second time I ran it, it says it kept the previous one, I guess previous memory, and then added and plays cricket. So likes to play cricket and plays cricket on the weekends, right? So the first one was just likes to play cricket. Oh, interesting. All right. And then this is the output of two of these, right? So this was metadata, likes to play cricket and plays cricket on the weekends. Okay. All right, so we got the memories. There you go. this needs to be updated. I guess, right? Likes to play. Did I type it? Yeah, I did. So it looks like it does modify the data somehow, right? Likes to play cricket on weekends. That was my memory, but then it stored it as likes to play cricket and plays cricket on weekends. Okay. And single memory by the memory ID. So this would be this one, I guess. Category and then searching. Okay, and then you do the search. So let's do. I'm not gonna create it again because looks like it is storing. Like this memory is. It has like a default. There's a default config, right? Which I didn't specify any, so it just uses the default one. Default vector store config. It is using a default one, but I don't know which one. Quadrant, I guess. Maybe it's that one. I don't know. TMP. Let's see. Yeah. Okay, so it's there, right? Yeah. So there's something there. Okay, so it sets it up. Yeah, it sets it up automatically for you. So that reminds me similarly the way that Embedchain worked. You didn't have to specify anything. It just magically worked. Like it defaulted for you. All right, so that's stored there, and then you can do a search. So let's do related memories, search, query. So let's do this. Let's add another memory. Likes to run during the weekday. And then user ID will be Peter here. So we'll add that one, and then we'll search for query is going to be what are Alice's hobbies? Hobbies. So we'll check that, and then we'll add another memory. Um, Watches TV series. And Alice as a hobby, and then let's see what we get back. So related memories, and we'll print those out. Let's do this. Let's see what we get. All right, so these are the related memories. There you go. Okay, so enjoys. Let's see. Can we do? Let me comment this out. I can do JQ to format, right? No, I guess not. I thought I could. Oh, it's not. It's not. It should be JSON, right? Oh, it's the. We can do JSON dump, right? What is it? JSON dumps? Is it like this? Let's try this. Oh, not like this, right? Yeah, there you go. There you go. Yeah, this looks better. So JSON dubs gives us a proper JSON, right? And then I can pipe through JQ to get this nicer output. All right, so this is the results or related memories for the query. What are Alice's hobbies? So enjoys watching TV series. That was one, and then likes to play cricket. That was the second one. Score. I don't know. Is this probably 33%? I guess. Does it say similarity score? Yeah. But why is it so low? Right. I would think that these would be like 100. Right. So what if I do? Let's say. Enjoys watching comedies on TV. Let's see how the data gets updated there, or memory, I guess, not data. Well, it is data, right? There you go. Okay, so this is how it updates it, right? So it knows. So when you add a new memory, and this is me doing some guessing here. So what I'm guessing what it does is it whatever you add a memory, it goes and tries to find if there's a related memory or a similar memory already stored in a database, and then it updates that one. So instead of adding a completely new memory, it updates the existing one. Um, and maybe it'll explain it somewhere else, but that's what I think it's doing here. So if I would do, um, uh, I love Seinfeld, right? Seinfeld. My guess is that this memory will be updated. So let's see. Ah, there you go. Yeah, see? Yeah, there's still two of them, right? But it updated the existing, so it kind of figures it out, right? Which memory is which memory to update. All right, so this is interesting. So I'm guessing this is a single entry in the database probably, which kind of maybe it also like saves them data, I guess, because you don't have to create separate entries for everything. You just update an existing one if it's similar enough. Interesting. All right. Oh, and you can also likes to play tennis on the weekends. Oh, this is updating. Is updating the same as add, or does add do the update behind the scenes? So let's see how add works. So create a new memory. Okay. See, just defaulting. If not prompt, what is prompt? Oh, you can do a specific prompt. Oh, there's a memory deduction prompt. So let's do. So deduce the facts, preferences, memories from the provided text. Just return the facts. Let's do full. Let's go full screen here. All right. So this is when you're creating a new memory. So what it does, we're not providing any prompts. So what it does is creates a prompt that says deduce the facts, preferences, and memories from the provided text. Provided text is I like watch TV or whatever. Just return the facts, preferences, and memories in bullet points. So natural language is whatever you pass in, and then user agent details is the metadata. And then it says constraint for deducing facts, preferences, memories. The facts, preferences, and memories should be concise. Don't start with the person instead of likes pizza. Okay. All right. So let's see. I want to try this. I mean, we could debug this, but let's see. I'm gonna go with Claude here, and what I'll do is what was our. So let's start with this one. Likes to run during the weekday. Oh wait, let's go back. I want to see what it does. All right, so it does that, and then it generates the okay. It generates the response. It's basically says you're an expert at deducing facts, preferences, blah blah blah, and the prompt. So it gets back the memories. Let's. I'm jumping through too many things. So let's go. Let's go and try this. So let's do this, and then user input was likes to run during the weekdays, and then category will be hobbies, right? And let's see how it does. We can close this one, right? Okay. Oh wait, metadata. Oh, it's not none. Okay. Okay, does embed the data, creates embeddings for the data because then it search for it later on. Okay, metadata. So we'll do metadata here. Oops. What was the metadata? This, right? Category hobbies, just for fun. I just want to see how the. Okay, let's see. This is not OpenAI, so there you go. Right. All right, so it returns it in basically bullet points. Right. Likes running, prefers to run on weekdays, which is exactly what we said. It didn't incorporate the hobbies anywhere, but that's fine. So let's see what happens next. Okay, so we get the response back, and I think this is just a direct call to like an LLM. My guess is, what is LLM here? LLM factory create. Yeah. I think this is just a wrapper around whatever the chosen LLM is. Okay, and then it says existing memories does a search through the vector database. There you go. And then it embeds the data. So embeds the data is likes running on weekdays, creates embeddings, searches for an existing memory if there is any. And then it says existing memories is this is Pythonism. Oh, I guess it goes through whatever it found in the database and then creates a memory item out of each one. And that memory item is an ID, score, metadata, and then the actual like text that was there. Serialize existing memory item model dump include. Okay, so just creates, I guess, the thing. Get update memory messages. What does this one do? Content, template format, existing. Okay. Now it updates the memory. Okay, so if it found something, right? Get update memory, existing memories. So let's see. So whatever it found, right? Serialized existing memories. So it passes in existing and then extracted. So existing, and these are the extracted. And then he uses this second prompt to says you're an expert merging, updating, provide little access to merge. Oh, okay. And this is where it's merging it, right? And guidelines, however it should do it, and then the existing memories and new memory. All right, so we can try this, right? So we can try this second prompt. And in this one, we would basically have, so existing memory would be likes, yeah, likes running, I guess likes running on weekdays. I don't know if that's the exact like way that it would be stored, but anyway, the new memory would then be doesn't like running in rain, for example, right? So this should now give me back updated memory. Yeah, there you go. Yeah, I would probably remove this one, but this is Claude. They're using OpenAI, so it's different, right? Yeah, there you go. Likes running on weekdays, doesn't like running in rain, so it's updating that existing memory. Okay, so this was in utils. So let's go back to here. Okay, so it got the updated memory and then tools. Oh, okay, so they're also using tools to so add, update, delete, and let's see what these tools do. I was looking at tools, I think in my last stream. Let me check, which was a while ago, I guess. What was it? Let me see. Yes. So I was looking at Crew AI. Oh, tools, functions, and agents. I think that one's the best one. Well, better than the Crew AI thing. Let me paste this one in here if anyone wants to take a look at that one. Yeah. So I was looking at tools and all that there. So the idea here is that in addition with the prompt that you're sending to the LLM, you're also sending a definition or more definitions of functions that LLM can not invoke, but tell you to invoke them, right? So in this case, you're telling the LLM, hey, there's an add memory function, there's an update memory function, and there's a delete memory function, right? So what it does is, so this is what we got back, right? This was the response, the messages, right? That we got back. So now what we're doing is we're making a call again here, right? Generating a response. And I'm basically telling the LLM, hey, based on this output, which of these three tools, well, actually based on this as well, right? Uh, which one of these three tools do you think I should call, right? And then the LLM will respond with in this tool calls portion of the response that you get back, right? And it's going to tell you, hey, I want you to run whatever, right? And this is where they're checking, right? So you get back the tools calls, and we're checking if it's set, right? If it's not none, and then we're saying, well, here's all the available functions. So these are the function names. Note that these are the same as when we passed them in here, right? Define them here and then pass them in there, right? And then we're just mapping them to actual functions that we've implemented already, right? So we're going through that. We're figuring out what LLM is telling us which function to call. We actually figure out whether we have that function. This is here, right? And then which arguments to pass in. Notice that in the function definition, you're explicitly specifying what are the parameters, right? What are the parameters for the add memory function, right? So there's one parameter here. It's called properties. It's an object. It's type of string, right? The field name is data. It's a type of string, and this is the description. It's the data to add to memory, and then there's you're also saying that it's required. So question between what is the difference between this and RAG? So RAG is more of you're providing the LLM context on context that it can use to formulate a response for you. With the tools, you're telling it, hey, I have implemented these tools, and based on my prompt or based on my prompt, tell me if I should invoke any of these tools. And if I should invoke them, tell me the name of the function and tell me the arguments that I should pass to that function, right? So it's a way to, I guess, extend the LLM, right? Because LLMs can't necessarily call functions for you, right? They can tell you based on the context and the prompt and the data that they have from RAG or from wherever, right? That, oh, I want you to call this function you user, right? Or developer, I guess, not the user. You should call this function, and here's the parameters that I want you to call. And then once you do that, you send the response back, right? So that's what happens here, right? We get the arguments, we get the name, we for function name, if function name, oh, okay, it's if it's add or update, we're also setting the metadata, and metadata is coming from, yeah, it was whatever was passed in, and then it actually calls the function, right? So function to call, what this one does, it either calls it calls one of these three, right? And then it gets the result of that function, and it's basically adding it to, let me see what the response, okay, it's just a response. So basically adding the result of that function and the data that the function, I guess, response, fetch the memory ID from, oh, okay, gets the memory ID from the response. Capture event, I guess this is for their own tracking, telemetry, yeah, this is their post hoc tracking, and then capture event, and then just returns the response, right? So this is how it creates a new memory, right? And then retrieving the memory is just a matter of going through the vector database, getting all is the same, just some filtering there. Searching does the embeddings for the query here, does the search, and then returns all the relevant values. Updating, it just calls the update memory tool. Oh yeah, let's look at the, said add, what were those three functions? They're here, right? Tool calls, create memory tool. All right, so creating memory with some data. So it embeds the data, creates a new memory ID, sets the metadata, inserts the data into the vector store. And I guess this is just for tracking stuff. So create, update is the same, just interacts with the data, right? And then deleting, same thing, just goes and deletes stuff. Chat is not implemented yet. All right, looks like this was at least one of the files that we were able to go through. All right, so it's combination of prompts and tools that does that. All right, let's go. Let's continue here. So memory history. Oh, okay. So let's see the history. I'm assuming this is the history of what was done, i.e., this was created, this was added, this was removed. I saw that. Where did I saw? Whoops. In the create memory, right? Create memory tool here. There was. There you go. See the add history. So there's another database that's just for tracking, I guess, memory history, like how was history manipulated, I guess. But we'll see. Let's take a look. So memory and dot history. Oh, we have to specify the memory ID. All right, so I'll grab this one. This is the watching TV comedies Seinfeld. So it's a merge of 3 memories, right? Memory ID and history, and I'm assuming this is JSON, so we'll do JSON dumps history print this. I should import JSON at the top. Let's do that. Import JSON. All right, so oops. There you go. Let's run it. So we'll get the history of. Yeah, there you go. Right. So this was the first one. See, oh, okay. This is interesting, right? Because it allows you to rebuild. Yeah, you can always rebuild and recreate, and then also probably interesting for tracing, right? Because you can go back, not back in, it is history, but you can go back through memory, if you will, right? And say, oh, what did this uh, uh, what did what did this thing know about a person? It was Alice, whoever we had here, right? Back at like before this timestamp or after this timestamp, so you can actually go and figure out, right? Pretty clever, right? So yeah, so we added the initial one, then previous value was whatever we pasted in or created it, and then it did an update which had merged the previous one and the current one because we said we want to do comedies. The only thing that I would add here is the actual what was the new memory, like a verbatim value that was created, because from this one I can deduce that it was uh, uh, they like comedies, right? But I don't actually know what the value was. So previous value, uh, uh, pre-update value, and then new value or whatever, right? I'm missing another value here, right? And then the last one, yeah, this is interesting. All right, so that's the same, and then deleting. So let's try this. I'm curious if I would delete the middle one. So let's delete this one was comedies. So if we would do, I'll still output the history, but I'll do memory delete. Memory ID is this. So we're deleting the fact that we like comedies. And then I'm curious how the history will change. So what I'm expecting is in this history, so enjoy watching, especially comedies, love Seinfeld. Next one will be event will be delete. And the new value will basically be enjoys watching TV series, loves Seinfeld without especially comedies, right? But let's see. It's my guess. All right. Oh, okay. Interesting. So enjoys watching TV, especially comedy. That was the first update. This was the Seinfeld update. Okay, so this one says one is deleted. Oh, interesting. Oh, why is the new value null? Let's see, because I deleted the. Oh, because wait, I delete? Oh, of course, because I deleted the whole thing. I should have deleted. Ugh. No. All right, so I should have deleted. Let's delete this one. I deleted the like the. Oh, but this is the history ID, right? Yeah, yeah, yeah. This is the history ID. Interesting. Okay, so let's take a look at how this is stored. Oh, okay. So this is just going get history by memory ID, selecting. Okay, just selecting the value from the database. Memory ID. Yeah, I would expect. Oh, maybe I misunderstood or I messed up something. So if let's delete everything. So if we delete all, because this was not a memory ID here, right? So this is a memory ID, which is exactly the same, right? Yes. Yeah, yeah. But at this point, now because we deleted the memory, we don't know anything about like if I we would ask uh where was the query? So it was memory, let's see, memory dots, was it search? Yeah. What are Alice's hobbies? Right? And then let's print result, print JSON dumps result. Let's do that. Yeah, because we deleted the memory, it doesn't know about it anymore, right? It's just likes to play cricket. Okay. All right. Yeah, I was thinking if there's a like if there's a way to remove a specific so if I go back, like in this case, right? So I basically have three history entries for that specific memory. So what I wanted to do is I wanted to delete a like a point in time, like a piece of information, right, from the memory. And my expectation was that I would like the memory would still be there, but it would be without this comedy portion here. But anyway, all right. So this was quick start, pretty interesting. Let's see, OpenAI. So we have the okay. So you can go and specify the configuration. Yep, this looks similar to what how the Embedchain did it. Let me just see if, oops. Yeah, Grok is the same thing, just telling you which one to use. Uh, TPS, yeah, okay. So this is not. It's just picking the one that you want them to use. Shouldn't be too hard to switch. The idea here would be is just just provide a like an AI API gateway, right? If you have that, and then handle that at the gateway level, so you don't have to explicitly set these things here. Multi on. All right. Build personal browser agent remembers you build personal browser agent remembers user preferences and automates web tasks. Integrates M0 for memory management. Will multi on for executing browser actions. Will create a browser based AI agent that searches archive setup and configuration. So I don't know what multi on is. Let me see. What is that? AI agents. Yet another thing that I should look at probably at some point. Okay. Oh, no, I'm not going to sign on. I wanted to look at the docs. There you go. Motor cortex. Okay. Okay. All right. So not gonna sign up for this one. I'll try. I know there's excuse me other examples, but okay. So user data. So you define it. You add it to your memory. Okay, and then it uses based on your preferences, right? It goes and searches for relevant papers. Search limit 3 relevant memories. I browse. Command equals prompt. Oh, okay. So command. What is command? Oh, okay. Find papers. Oh, okay. 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 So this is basically just saying. So it's using the memory and just passing that in, right, as a prompt to this multi-on agent browsing thing, browser browsing, internet browsing thing. Yeah, personal browser. Yeah. There's a cookbook as well. Oh, this is just. Oh, okay. It's the same thing. It's just workbook that you can go through. Okay. All right. So there are more examples. There you go. Examples. There you go. So AI tutor, travel assistant, customer. Okay, let's do customer support agent. Where's the time? All right, 10 more minutes. Okay, so what do we need to do? So install the packages. Here's the example. So we're creating some class, customer support AI agent, getting ID, create your custom support. Okay, so this is just, actually, let me copy this. And then we can try it out in code. I'll just simplify it a little bit more. So let's go here. I'll comment this out. I'll remove this. Let's paste it in. Let's close this. And I think we can do this, right? Make it a little bit bigger. All right, so customer support AI agent initializes, config. Let's just say we don't, I'll just use by default whatever it is. And then we'll do from mem0 import memory without the config. Just use the default one. Okay, I need the OpenAI, I guess. So, oops, not this one. So let's do pip install OpenAI. Okay, and then from OpenAI, import OpenAI. I have the environment variable set, so that's all good. So setting the app ID to customer support, handling the query. This will just call the OpenAI completion chat completions, stream the responses, the system messages that this your customer support agent, right? And the query is whatever the user passed in. There's going to be a user ID as well. And then once we get back, so we're going to store the query that user asked per user ID and add the app ID to metadata. Then we're going to print the response. Okay, so we're not actually storing responses because we don't have to, I guess, right? So we're streaming the responses back. And then we have another function here that just says return get all memories for that user. We're creating the instance of the agent, sending the custom, and then support agent handle query. I need help with my recent order. It hasn't arrived yet. So let's see. Okay. So this will give us a response back. So response. Let's print the response here. Just want to see how it looks like. Oh, it's not from config because we're not actually. We don't have any config. We just want to use the defaults. Okay, so now it's asking me, right? Provide. This would be like a whole chat loop here. Could we do Streamlit? We could. Let me see if there's an example with Streamlit. Uh, oh, there you go. So there's an actual like a full loop. So let's do like this, right? So while true, question, exiting, support agent and customer ID. Let's call this user ID. User ID, support agent. There you go. All right, it's gonna print the memories, right? But at least we can chat with the thing here. So it's gonna remember stuff, right? So let's see. What was the initial question? My order didn't arrive. My order didn't arrive. Whoop. Oh, wrong. Copy pasting code blindly, right? So it's not ask question, it's handle query. It's handle query and query user ID. Okay, and then this is the same. Yes. So my order hasn't arrived. Okay, so I'm sorry to hear that your order has arrived. To assist you, I'll need a bit more information. Could you provide me with your order number and the date the order was placed? So these are the memories, right? Place a recent order. Order has not arrived. Needs help with the order, right? So it's awesome, right? And it stored what was the app ID, what was the user ID, and the actual data, right? So now we're gonna say, and I think it's sending everything back. I'm not sure. It might not. Let's see. So ask questions. Previous. No, we should fetch the previous memories. Yeah. Because this is not going to work. So if I say my order number was 1234 ABC, because we're not refetching it, right? Oh no, it is. Look at that, right? I'm sorry. Yeah, blah blah blah. It doesn't know, right? This is where we could create a function that goes and looks up the information about. Oh, let's do that. Let's do that. Why not? Right? Where was the? Just gonna steal the code a little bit here. So let's create a simple function that, what is it here? So it's saying, I'm sorry, but in AML, I don't have a customer databases. I can handle, okay. So what we'll do is we'll create a function that, a tool, right, that uh, retrieves order data, right? It's going to be fake, but just so we can see how this works more realistically, I guess. Where was that? Let's go. Where is it? It was here somewhere. Oh, no, almost there. Oh, there it is. So we're not going to have add memory. We'll call it search order DB function or tools. I'll just search order DB. Let's do that one. And we'll call this search orders. Search orders. There you go. Search the orders database. And what will we have to pass in? So we'll have to pass in order ID, string description, order ID, right? That's it. Order ID. And then we'll return back some fake data, right? So search orders. Oh yeah, it'll work, right? Over here, chat completion create. We'll do tools, right? Tools equals search orders. I just move this up there. Here, right? Go. So it's going to store that in a memory. And then over here, we'll have to check, just like they're checking here, right? So when we do we can do, well, you could do streaming, but let's just don't do streaming. It's easier, right? Chat response, and we'll just print. It's not gonna be nice, but we'll print it easier, right? So we'll print the response. Oh, and let's see, what is the choices 0 content, right? So it's choices 0. I think it's message content, something like that. We'll see soon enough. And then we'll say, so we'll check if, same thing, tool calls equals response, chat response, tool calls. And then we'll say if tool calls the, for tool call, yeah, go through all of them. If tool name is search orders, which it is, get the order ID. We don't have to add that to memory, but we can call the search order ID. And then over here, we'll just return some order information. Let's say order ID, customer was it Jane Doe, status shipped, or items, whatever, something like, doesn't really matter, just fake it, right? Search orders, and then over here we'll actually call the function, right? So we'll call the search orders. Oh, response, sure, yeah, call it like this. And then we'll need to do the response. Let's do here, because we'll have to send it back, right? Response equals this. Response. Oh, wait, response, chat response. Let's print it out there. So store it. We could store it earlier, right? Store it here. Then make a call. Then print out the response. Then clear the response. Oh, get the tool calls and clear their chat response and build it back again, right? Because we'll send it back. Over here, search order response. We don't need this. We'll do response chat response dot append append capture. Is this sending it back? Yeah, something like this. I'm not sure if it's like that, but this would basically call the function, and then we would have to send it back, right? Let's see what they have here. Fetch the previous related memories. Message append, generate response, append the message, store the memory in question. I think it's probably not going to work, but I was trying to rush through it. So let's see. My order hasn't arrived. Yeah. Chat control. What did I mess up? Can you please provide tool calls, chat response tool call? Oh, I should probably check that it's not null, right? This one, right? Oops. Let's print the whole chat response here. Oh yeah, it's not going to be, the tools calls is not going to be there, right? So we can do get, right? Something like this. Yeah, and then if it's null, this over here, like this, right? It's Friday. It's been a long week. I'm not thinking straight anymore. My order hasn't arrived. Me. All right. Why is the chat response? Chat has no attribute get. So this is telling me that this one is, let's see what is in chat response. Order hasn't arrived. I'll look at the last example as well. So, and then what I'm doing is chat response that get tools call. So chat response. Yeah, there's no tools calls, which is fine, but I would think that so then it's asking me for, why wouldn't this work? I don't get it. But ID would work, right? So if I do .id, this will print out the ID. Do chat response like this, right? Oh no. This. Order hasn't arrived. Yeah, so this works. Why is it? What? Oh, it doesn't have the attribute. So let's do check if the attribute exists. Where is it? It's weird that I always get tripped up by the simplest thing. So we'll say check whether the tools call. Is it tools calls? Tool calls. Where is it? Tool calls. Oh, but it's not there, right? It's not in. It's not in messages, right? Let's do it this way. It's not going to fail now, but it's not going to work either. My order hasn't arrived. If that one prints out none, then it should work. No, it's weird, right? Object is not subscriptable. That doesn't make any sense, but why does this work? Like this should return me none, right? No? Attribute error. All right, let's do this. So let's do tool calls. Let's move this one up here. Oops. And over here, we'll say try. Try. Accept attribute error, pass. Right. So we're gonna, if we can't get the tools calls, we're not gonna do anything. It's gonna be empty. If it's gonna be empty, we'll just do this here, right? There you go. So we actually return response. My order hasn't arrived. There we go. All right. So this is better. So I sure be happy to assist you. Can you provide me and yeah, see, no. So it should theoretically, we should look up the order ID, right? Not necessarily the function. So okay, so if we say my order is 1, 2, 3, 4 ABC, I'm trying to see if it's going to call the function or not, right? No, it's not, right? Oh, it is. There you go. There you go. See, function. There you go. It is calling the function. Yeah, so it is calling the function. I'm just thinking it should, instead of doing this, right, it should check the order, right? Uh, so handle query. So we're going to add the memory, but then we also would have to like retrieve the existing memories, right? Like here, this one has search memories. Oh, yeah. Let's do that. Let's quickly do this one as well. Search memories. So we'll just do this. So we'll implement it here. So you can basically combine it with function calling and memories, right? And memory. So search memories, and then how do they do it? Or here. There you go. So we add the current memory, then we say previous memories equals self.search memories. Query is query, user ID is user ID. All right, so we have the previous memories. And then over here, we'll do like query, right? So this is the user query. And then we can also say previous memories, just like they're doing it there, right? So theoretically, I'm thinking the it should now know that the order number is 1234 ABC. So let's add a print line here. So we'll say print searching order. There you go, right? So it shouldn't ask me what is the order ID, or maybe it should, right? It should ask me, oh, is this the order ID, or is it something else? My order hasn't arrived. All right, so and so yeah, there you go, right? See, tool calls. It went right away and searched for that order, right? It's not asking me anymore what is the order ID. It knows based on the memory, right? It knows that this is what my order ID was. So if I clear the memory, so we'll do I'll just do it here. Self dot memory dot, is it reset? Yes, just reset everything. So we'll start from scratch. And now if I'm going to ask it, whoa, what did I do? I closed it. All right, so my order hasn't arrived. Now it shouldn't know, and it should ask me, right? Or it should fail. Why is it failing? Oh, maybe because I did reset, created it, and then reset it. Let's try again. My order hasn't arrived. Oh, there you go. Yeah, see? See, now it's saying, sorry to hear, provide me the order ID, right? And the memory is order has not arrived, right? And then I'll say, now if I say my order ID is blah XYZ 123, why not, right? It should go and invoke the function. Yeah, there you go, function, right? So it's telling me go and invoke the search orders function with this order ID. I haven't implemented that, obviously, right? But it also updated the order ID in memory. So if I say my other order hasn't arrived yet, so many typos. Now it assumes that that's the order, right? Place it does know that it placed the other order, right? But anyway, all right, let's quickly go through. So this was the travel assistant. So the same idea here, right? It searches the memories. If there are any previous memories, it attaches them as prompt, sends it to the LLM, gets back the message, stores the. You could store this. You could store this at the beginning, right? But anyway, stores the question. And then what was the other one? So support agent, personal tutor, travel. So tutor, travel, customer agent. So let's do personal tutor. And so I guess this is the same, right? Question. Oh, we've seen this one, right? Yeah, this was the first one. Oh, which is the same as the last one, right? Yeah. Anyway, definitely interesting. I'm curious to see like the implementations of these of this memory of the memory thing, right? Definitely an interesting idea. I would add the removing of specific I guess it's not a memory. Memory is the whole thing, but removing like a piece of memory and then having the memory be rebuilt. And then I'm also curious, like, how would one implement this, right? So let's say I'm doing like a support for orders or whatever, right? If I go and ask and say, "Hey, my order has not arrived," first time I do it, it's going to ask me for an order. But then if I do it a week later, it should not assume that it's the same order, right? So it's almost a way that I guess I'm not saying it's not part of the memory, probably, right? But it's probably you would have to figure out, right? When you're searching memories here, get the previous memories, and then say, do the uh, forgetfulness, right? I have to forget that previous order, or maybe not, right? But basically, I'm there has to be like a something else to the prompt here that says, here are the previous memories, but don't assume anything, right? Tell the user this is the previous order that you asked about and hasn't arrived, and then ask them if this is in regards to this order or a new one, right? For example. But I guess that's not the I don't think that's in the purview of the memory itself, right? It's the application. All right. Anyway, yeah, this was it's definitely interesting. I like the idea, and since it's a database, right? It's you can use it across different applications. It's just a database. It's just an API. I'm assuming there's going to be like a SaaS version of this one or a hosted version. I think I saw platform. Yeah, yeah. So there is like a platform. I think you can. I don't know if you can sign up already or not, but yeah, there's like a platform where you have where everything is basically stored there, right, in the cloud, not in my TMP folder on my machine, right? Uh, yeah, I'm just looking through. Yeah, there looks like there's some UI around it already. I just don't see any way to where I would be able to sign up, but I get the idea, right? It's almost like it's sign up there, collect all the memories there for your users, and then if you have multiple like applications, or you can reuse the same thing across multiple applications. Yeah, and then all the like observability and management and everything that comes with that data is probably provided by the platform as well. All right. Anyway, yeah, this was interesting. Thanks to anyone who stuck with me, and I'll see you next time. Bye.